All right, so the purpose of this video is to talk a little bit more about displacement and the area under a curve when we're dealing with displacement. And so this is kind of the main thing we're looking at right here. The area under the curve, or the slope of a velocity versus time graph, is displacement. And so I want to try to do a couple of things with that. And so we can set up a scenario, and I set it up here to show you the original scenario. If you started out on this guy right here starts out at 0 meters, his position is 0. You give him a velocity of -6 meters per second starting out, and then an acceleration of 6 meters per second. And we want to walk through and see, well, what would that displacement look like and how would we find that area? And so the first thing that we could do is excuse me, is find the thing that just disappeared from my screen. Here we go. And to find the area under this curve, we would need to think about this area right here. All of this in here. And then also all of this in here. And so to do this one, we would use our equation. And our equation for the area of a triangle would be 1/2 base times height. I went ahead and put this in to save time. 1/2 1 times -1. Now it's really important that you would notice that this is a -1, -6. That's a -6 because this is the height right here. This is the height of -6. This across this way, this is the base, and of course that is at 1 second. It may be hard to see, but this is 0 seconds, this is 1, this is 2, and then the final part is 3. And so that's why this would be at 1 second. So that would be 1. So the area of this is -3. How would we find the area of the other one? Well, we would do the same thing. And we would find that the same thing on this one. The area of this top section is 12. Now, so the way we would find total area would be, we'll just call that a T for total. It's going to be the sum of these two. So that would be 12 plus -3. So that's going to equal 9. Now, since we know, back to our original statement at the very beginning, since we know that area under the slope or curve is velocity or displacement, then we know that then displacement in this case is going to be 9, and we'll put in our SI units because we put in meters per second, would be 9 meters. Now it's worth noting that we can actually see that on our graph here as we play it back. If we start back over, let's go back to playback. Where did he start? You can see basically he started at 0, and as he started traveling, you can see right here as we're watching, this is telling you what's happening in the playback. When this velocity gets to 0, you'll notice him start to stop. See that? He stopped and he actually changed directions as he passed that. Let's back up. I'll play it through a little bit so you can watch it go. As he goes through, when this line crosses the 0, he changes direction. Now, as he keeps traveling, now he's moving in the positive direction. You can see him moving along. And when we get to the end of this 3 seconds, when he gets to 3 seconds, we're watching up here for 3 seconds. You can see he's going to be at that 9-meter mark. Now there's some rounding in here, so it shows it slightly over, but it's because we're rounding the nearest tenth. But basically he's at that 9 meters. Thank you. I hope that helps, and best wishes.